Okay, hello folks. So today we're going to look at how do we solve the kinetics lab and how do we understand kinetics. The first thing we need to understand is what is kinetics. Kinetics is the study of how fast reactions are. How do we control their speed and how do the reactions actually occur? We're understanding the basics of essentially collisions in a gas or liquid phase. So our experiment will be using color change and timers. We're going to essentially measure how fast a color disappears. So we're going to look at the lab. The basic idea here, is that in this lab we have essentially we're mixing a bunch of things together: iodine, bromate, acid, and that's going to form from iodide to iodine and to bromide and then be converted back. And so we're going to need to measure a reaction rate, the rate of change, the rate of decay of bromate in this case. And we're going to try to find out the reaction rate, the reaction order with respect to each guys. The idea of reaction order is simply that hypothetically, how much would a reaction speed up when I increase one of these values? It's like you imagine some guy, a group of construction workers working on a brick wall. If each guy is working on the wall separately, in a first order mechanism, every time you add a worker to the wall approximately increases by the speed of that worker, because each guy is working on his own thing separately. They're not helping each other, but they're not hindering each other, so they're each building independently. And so if I double the workers, I should double the speed at which the wall gets built. In a zero-order mechanism, no amount of change will speed up the reaction. So if I add a lazy construction worker who's just going to sit back and manage from the distance but not going to actually do any building, doesn't matter how many managers I add, the wall doesn't get built any faster. So there's certain reactants that do not speed up the reaction. They are still necessary, but they are not part of the slow step that actually the work needs to be done. And certain guys could result in a secondary, a reaction order of 2, a second order reaction, where every time I increase the number of molecules, the rate goes up by a square of that increase. It's like a synergistic effect in that it's like if the workers, instead of working on their separate thing, each took their own little task and helped each other, maybe they can do faster. Like one guy building that wall, if it's a brick wall, maybe one guy's mixing the mortar, the other guy's carrying the bricks, one guy's placing the bricks and smoothing it. That together they can work faster than if they were each working on their separate bit of wall. Because that means they don't have to mix their own mortar. They don't have to stop and go get more bricks, because there's always more bricks waiting. So by working more efficiently, they can grow faster. So there's first order, zero order, and second order reactions. And we can learn that by modifying reactions, changing just one value, and looking at how the rate changes. How we're going to measure the rate is by measuring a change in concentration of one item divided by the time it takes for that to occur. So we're going to run the clock reaction, which the slow step is we form iodine, and then the trace amount of S2O3 turns it back to iodide, and that's very fast. When that all runs out, it's essentially it will stay iodine, and so only once it's fully used up will we see the deep blue color that will permanently form. So there's some other things in there, but so you'll notice here, we'll be making a series of reactions here in this table. This table shows everything we're going to do. We're going to make 4 different sets of flasks with flask 1 and flask 2. Flask 1 is going to contain potassium iodide, the sulfur S2O3, water, and bromate. 10, 10, 10, 10, 20, 10, no water, 10, 10, 10, 20, 10, 10, 10, and this one has 20. This one's going to contain HCl and starch, and we're going to mix those together. Once we mix them together, reaction's going to start to occur. So each one we're changing one of these 4 components. The Ki, well actually we're not changing the S2O3, we're Ki, the bromate, the HCl. But you should notice the final volume is 10, 10, 20, 30, 40, 50. 20, 30, 40, 50. 10, 20, 40, 50. 10, 20, 30, 50. 50 mils more or less total. So we're mixing those guys together. So scrolling all the way down. The first to the Prelab. The first thing they want us to do is supposing a student takes a reaction mixture 2, table 1, mixture number 2 and table 1, where the contents of the reaction flask 1 and 2 are mixed together, and it takes the time it takes is 75 seconds. 75 seconds. Now calculate the initial concentration. So how do we calculate initial concentration of all values involved? We're going to use our dear friend M1V1 equals M2V2. So we want to find our new M2. They are a show example calculation of S2O3. So it started with a concentration of 0.0010. We had 10 milliliters, and we divided by 50 milliliters, and that gave us our new concentration. So we need to do the same thing for iodide, bromate, and acid for each one. Each one is going to have a total volume of 50. Then we're going to calculate the initial rate of reaction. Then for question 2, supposing the amount of time needed to turn the mixture 1 blue was 145 seconds. Calculate the initial concentrations of the reactants after mixing mixture 1 and use. So mixture 1, 145 seconds. So determine the reaction order with respect to iodide. Okay, so let's go to the document camera now. So you'll notice I have put our table. So in reaction, we'll only be using reaction mixture 2 and reaction mixture 1 for this problem set. So reaction mixture 2, we need to calculate what is my molarity of Ki. Well, the molarity 1 of Ki is 0.010 m. My volume 1 is 20 milliliters, and my volume 2 is 50 milliliters. And we're going to repeat that process with the potassium bromate. Potassium, that's with our Ki. Our potassium bromate, the V1 is 10, and the M1 is 0.040. Final volume is still 50. And so M1 is 0.040, and V1 is 10 mils. V2 is the same, with H plus for the HCl. The M1 is 10 is 0.1, and the V1 is 10 mils. V2 is still 50. You can do those calculations. So then the second part asks you to calculate the rate. The rate is just going to be the molarity of bromate divided by the time it took. Well, you will have the molarity of bromate. The M2 for that is going to go there. The M2 for bromate is going to go there. The time it took, they told us at the very beginning of that question 1, it took 75 seconds. So how long did it take the new concentration of bromate to go? That's going to be whatever that concentration is divided by 75, and that's going to give us units of m over s, molarity per second. So, with that in mind, then they want us to look at reaction 1. If reaction 1, the mixture 1, took the time of, I think, 145 seconds. 145 seconds. How long? How would that have changed things? So the M2 will be the same because the volume is still 10. Number 1 had 10 mils, number 2 had 10 mils. The only thing that would change between reaction 1 and reaction 2 is that at 20 mils the second time, the concentration of iodide has doubled. So whatever your M2 is, you would divide that by 145, and that would be your rate 1 answer. And that would be in molarity per second. That's your rate 2 answer. Now with those in mind, rate 2 divided by rate 1 should be somehow proportional to iodide for your second one divided by iodide to the first one. It's going to be raised to whatever power. So, no matter what, the concentration, whatever those concentrations are, the concentration will have doubled. The concentration will have doubled because we went from 10 mils to 20 mils. So if we look at the rate, if the rate has doubled, that means x would have to equal 1. If the rate has quadrupled, or thereabouts, then x would have to equal 2. And if the rate has not changed, even though the concentration has doubled, then x would have to equal 0. And our goal is to see how the rate from reaction set 1 and reaction set 2 has changed, and use that to find out what is the effect of iodine. And in lab, we'll do that to find out what is the effect of bromate, what is the effect of acid as well, because all of those will get changed at some point from the reaction mixture. We probably won't do the one that involves changing the temperature. So that will be what we'll do. But that is how you go about attacking this prelab. It is not a super long one. It looks long, but it's only a series of M1 V1 equals M2 V2s. From that, it's just dividing those concentrations by time. So in itself, that shouldn't be overly challenging. Good luck.